This lesson we're going to talk about rational function and their graphs. In order to graph the rational functions, we need to recall that fraction form of functions always have restrictions, right? Where your x value cannot be equals to 0 on denominator. That's going to give you your vertical asymptote, right? And horizontal asymptote, we have few method of finding horizontal asymptotes, and it's given here, and I will show you using example how exactly you're going to find the horizontal asymptote. Sometime when you don't have a horizontal asymptote, you're going to have a slant asymptote. So that's going to be big difference between different other function compared to the function we're going to looking at this sections, which is rational functions. So we're going to start by going over example 1, where you're going to see or learn how to find the vertical asymptotes. So vertical asymptote, what you need to do is you're finding restriction of your x, right? So we did that before. How do we find the restrictions? We will say let denominator equals to 0 and find the value where your denominator will become 0. That will be your restrictions. So in other words, that's the number that you can never have, because fractions you cannot have 0 on denominator, right? So you cannot have 0 on denominator. That's your restrictions. So it means your vertical asymptotes. On the first example, x can never be equals to 0. What about b? If we wanted to find the vertical asymptote, same thing. You're going to find out what value of x will give you denominator equals to 0. Whatever that value is will be your vertical asymptote. So basically let them equals to 0 and solve it. You should be able to factor this. So this is going to be x plus 2 and 3x minus 1. It means your x can never be equals to negative 2 over 1. You could say that's just negative 2, right? From the first parentheses, and second parenthesis, x can never be equals to positive 1/3. So that's the restriction, and your restriction will be your vertical asymptote. The third one, when you solve this, this is going to give you negative. And when you use the square root property, it will be x equals to plus minus square root of negative 4, which is imaginary units. Once you get not a real number, it means you will not have vertical asymptotes. So no vertical asymptotes on that one. Because what you found is not a real number. It's imaginary number, right? So that's why there will be no vertical asymptotes. So what about the fourth one? Let's try that also. Subtract both sides by negative 9. And you will see that when you do square root property again, you get negative radical, which is going to be, again, no vertical asymptotes. Now we're going to look at how to find the horizontal asymptote this time. Horizontal asymptote. So in order to find the horizontal asymptote, we're going to use the first term. So when we go back and look at the standard form of rational functions, right? Your first term, a to the nth exponents times x to the nth exponents. No, a sub n times x to the nth exponent over b sub m x times m's exponents. So in other words, you have a leading coefficient for the numerator, leading coefficient from denominator, and you have different exponents, numerator and denominator, right? So we're going to use that information, right? With that, we should be able to tell different horizontal asymptotes. So first, when you're comparing n have to be greater than m, then f has no horizontal asymptote. So in other words, your exponent denominator is smaller than numerator. So numerator exponent is larger, then it will be no horizontal asymptotes. When the other way around, numerator exponent is smaller, then your horizontal asymptote is going to be 0. And when numerator and denominator exponent is same, then your horizontal asymptote is going to be leading coefficient from the numerator over leading coefficient from denominator is what you're going to have. So using that, let's look at this. You can see that this is square and this is fourth exponents. So look like the numerator is smaller. So when you have a numerator smaller, your horizontal asymptote is going to be y equals to 0. What about the second one? Second one, you have a cube and square. Your numerator exponent is larger this time. So that means you're going to have no horizontal asymptote. What about if you have a same exponent, square and square? Then your horizontal asymptote is going to be leading coefficient of numerator over leading coefficients of denominator, which is going to be just 4, right? So that's going to be your horizontal asymptote. So it means y cannot be equals to 4. This is y cannot be equals to 0, right? So if I write that information again, if we have ax to the n's exponents over bx to the m's exponents, where numerator exponent is larger than denominator exponents, there will be no horizontal asymptote. And if you have numerator exponent is smaller than denominator exponent, there will be y equals to 0 horizontal asymptote. When this is the same, exponents are same, then you have a over b equals to y as the horizontal asymptotes. Remember we talked about the slant asymptote also? So slant asymptote occur when you have no horizontal asymptotes. And this is special case. So it will be slant asymptote if your numerator exponent is just 1 degree higher than denominator, then you're going to have slant asymptote. So something like case B, you're going to have slant asymptote because numerator is just 1 degree higher. So when you divide this, you end up getting linear, because when you're dividing it, you end up getting x left over. Then you're going to have slant asymptote. So let's look at the next examples to see that. So again, example 1, we did the vertical asymptote. Example 2, we did horizontal asymptote. Example 3, we're going to see that special case of the slant asymptote. So if you're looking at this, looking at the square on the numerator and the linear on denominator, it's just 1 degree different, right? So what you're going to say is there will be vertical asymptotes that x can never be equals to 2, because when you do denominator equals to 0, you get x cannot be equals to 2, right? That's your vertical asymptotes. And if you wanted to find horizontal asymptotes, because the numerator is higher, numerator degree is higher than denominator degree, it will be no horizontal asymptote. But because it's 1 degree different, it will be slant asymptote. And how do we find that slant asymptote? That slant asymptote will be basically dividing this two to find that linear. That linear will become your slant asymptote. So let's do that. It will be 2x squared minus 5x minus 3 divided by x minus 2. In order to have x goes into 2x squared exactly, you need to multiply by 2x. Once you multiply 2x to the x minus 2, you get 2x squared minus 4x. Now you're going to subtract, right? So subtract become this addition. That will give you 0. That will be negative x. Bring down the next digits because you do need 2 digits to do divisions, because you have 2 digits right here, right? And then repeat that procedure. X to become this x to become negative x, you're going to multiply by negative 1. When you multiply that to x minus 2, you get negative x plus 2. Now you're going to subtract, so this will change to plus x and negative 2. So that will be cancel out. That will be negative 5. Negative 3, negative 2 will be negative 5. So your remainder is negative 5. When you're finding slant asymptote, you do not need to have, you do not use the remainder. This is going to be your slant asymptote. So slant asymptote will be y equals to 2x minus 1 will be your slant asymptote. So your graph cannot be equals to that line. Okay, now I'm going to show you how to graph the full graphing from the rational functions. So the first thing we wanted to do, step 1, we wanted to find the vertical asymptote, all the asymptotes first, right? So find vertical asymptote, look like x cannot be equals to 1, right? Horizontal asymptotes, y, because it's the same exponents, right? First, so when you look at this, this is the linear, this is linear, right? So the same power. So it will be 2 over 1 then, right? So you will say y cannot be equals to 2 over 1, which is 2, right? And then step 2, let's see if this is any symmetry, right? In order to tell symmetry, you're going to replace x with negative x, so that you get 2 times negative x minus 1 over negative x minus 1. When you simplify it, you get negative 2x minus 1 over negative x minus 1. This is not going to be same as f of x. This is not same as f of x. All the signs are different. Not opposite, because you do have negative here. This is negative. It's just x is negative now, right? But then when you factor negative, this sign change, right? So that's not going to be even negative of f of x. So in this case, we will say no symmetry. And the step 3, you wanted to find intercepts. X-intercept and Y-intercept. X-intercept, we solve the given function equals to 1. When you multiply both sides by x minus 1, denominator cancel out, you will get 2x minus 1 equals to 0, because 0 times any number is just 0. So for x, you're going to add 1, divide by 2. So it'll be 1/2 will be x-intercept. And then the other one, y-intercept, is letting x equals to 0. So it will be 2 times 0 minus 1 over 0 minus 1. That will be negative 1 over negative 1, which will be positive 1. So now I have 2 points to mark it on a graph, and another 2 points that I know that will be the vertical asymptotes, right? So I'm going to graph that. And that will be step number 4. So apply all that information in a graph and see what I have. Let me mark the vertical and horizontal asymptote. So it will be x cannot be equals to 1. Y cannot be equals to 2. So that's going to be 1. That's going to be 2. Let me draw a little bit higher on this side. And then what else we have? We have x-intercept is 1/2. So it will be somewhere right here. Y-intercept is 1. So somewhere right there. So the rational function is smooth curved line always. So when I draw the smooth curved line passing these 2 points and not touching or crossing the asymptotes, I will have something similar to this. That's just the left side of your vertical asymptotes. Now you need to find the right side of the vertical asymptotes. If it was x-axis reflection, or y-axis, or what do you call, symmetry, right? Y-axis symmetry, then probably it should be on this side right here. So that way that I don't need to find other points. All this information will be enough to graph. But it was no symmetry, so we don't know where it's going to go, if it's going to be in this quadrant or this quadrant, right? Because your vertical asymptote, horizontal asymptote cut it into the 4 piece. And since we found the graph on the right side, we need to find the graph on the, we find the graph on the left side, so we need to find the one on the right side. And if it was y-axis symmetry, then it should be here. But it wasn't, right? So what I need to do is actually plug in any points that x is greater than 1 and see if my graph is upper area or the lower area of your symmetry. So let's do that. We're going to plug in maybe x equals to 2 then, right? So when x equals to 2, that will be 2 minus 1, 2 minus 1 on denominator, which gives you 4 minus 1 is 3 over 1. So when x is 2, y will be 3. That will be x is 2, y will be 3. So it will be right there. So whatever the points that you find after, you know that had to be greater than 2. I mean greater than 1. Yeah, greater than 2, which is 3 right there, right? So again, smooth curved line passing that point will be look like that. That's how you're going to find your f of x function graph. Let's try another one, B. So what do we do first step? Finding all the asymptotes, right? Restrictions. So x squared minus 4 cannot be equals to 0 gives you x cannot be equals to, that's positive 4 on the other side. And when you square root it, it will be plus minus 2 is what you're going to get, right? So that's going to be vertical asymptote. Horizontal asymptote, they're the same. Square and square. So your horizontal asymptote is going to be y cannot be equals to 3 over 1, which is 3. And then let's see if this is any symmetry, right? Negative, replacing x with negative x. Because you're squaring all the negative, you will get positive back. And this is same as what we started, f of x. Then we know this is going to be y-axis symmetry. So because this reason, we probably don't need to find the other side of half, right? And then what else? Intercept now. X-intercept. Letting y equals to 0. And 3x squared equals to 0, where x will be 0, right? Y-intercept. Letting x equals to 0. You're multiplying everything by 0 here, so it had to be 0, right? This is 0 over negative 4, which is 0. Maybe we do need to plug in a few points because you only have 1 point given. Finding intercept. So let's see what I have. And then maybe I need to find more informations here. So let's see, this is what you have. Let's mark all the asymptote. Negative 2, positive 2. So negative 2, positive 2 is your vertical asymptote. Horizontal asymptote is 3. So with this asymptotes, now you have how many different areas? 1, 2, 3, 4, 5, 6. Now you need to find where you're going to have all these points or graph. By plug in the intercept, right? But that only gives you 1 point. So what I need to do is I need to find more information than just 1 point. Let me see what happened when x is equals to 1, right? When x equals to 1 here, so I will know if it's going to go up or go down. Probably go down because you have vertical asymptote, horizontal asymptote, your graph cannot be passing, right? But we wanted to make sure, right? So then we're going to let x equals to 1. That's the 1 point. And then because it's symmetry, I only need to find the one side then I know where this is going to be. If I have a graph up here, I need to have a graph up there. If I have graph on the bottom, it will be the graph on the bottom on the other side because it was y-axis symmetry. So maybe I can try 1 and I can try 3. When x is 1, let's see what I get. Replacing x equals to 1. This gives you 3 over negative 3, which is negative 1. When x is 3, I get 27 over 5, which is 5 2/5. So if it's 1, it will be negative 1. So it will be somewhere right there. Positive 3 will be 5, 1, 4, 5, 6. So it will be between 5 and 6. Somewhere right here. So my graph should go down this way. Smooth curved line. Smooth curved line that's not touching asymptotes there. And this is y. So this is the half of the graph. But because it's y-axis symmetry, the other side, when you fold y-axis, this graph should be matching exactly. So it will be on this side and graph on that side. Right? That's how we can find the full graph without plugging the point. I'm going to try a few more examples. So this time we're going to try x plus 3 over x minus 2. Finding a vertical asymptote. This time your horizontal asymptote is 1 over 1, which is 1, right? 1 over 1. And then symmetry. We're going to let x equals to negative. And when you factor negative, you get x minus 3, x plus 3, which is, oh, that's 2, right? 2, 2, which is not f of x functions, nor negative f of x function, means no symmetry. Finding X-Intercept. You get x plus 3 equals to 0, where x is negative 3. Y-intercept. That will be 3 over negative 2, right? With that information, let's see what I have. So vertical asymptote 2, horizontal asymptote 1. This is 1, this is 2. And then you have no symmetry and x-intercept negative 3. Y-intercept is negative 1.5. Right? Draw the smooth curved line. Oops. Smooth curved line. The other side, I don't know if it's up or down, so we need to plug in points. I guess we're going to plug in 3. That's x, y, 3. It will be 3 plus 3 over 3 minus 2. So that will be 6 over 1, 6. So it will be somewhere up there, 6. It means it's upper versions. Graph is in upper visions, right? So that's the graph for the third one. Let's try another one. This time, you don't have vertical asymptotes. No horizontal asymptotes. Because numerator exponent is larger. So very, very small informations. What about symmetry? Because it's an even power, it gives you back with the positive. So this is going to be y-axis symmetry. X-intercept. Usually when you multiply both sides by denominator and this is 0, you only get numerator equals to 0. That's how I've been doing your x-intercept. So always it will be numerator equals to 0, which is going to be 0. Y-intercept, x equals to 0, will be 0. So all the information I have is very little. No vertical, no horizontal asymptotes. Only thing that I know is y-axis symmetry, and it passed through 0. So whatever the shape that I get on this side, I should get exactly same thing on this side. So because I have so little information, I need to actually plug in the points. So maybe let me plug in 1 and 2, right? 1 and 2. So then I get 1 over 1 plus 1, which is 1 over 2. 2 to the fourth exponent, so it will be 16. Over 2 squared is 4 plus 1. That will be 5, right? Which is 3 1/5. So when x is 1, it will be 1/2. When x is 2, it will be 3 1/5, so somewhere right there. Smooth curved line connecting those two dots look like that. So because y-axis symmetry, the other side should be exactly same, right? It looked like parabola, but that's what we have without the asymptotes informations. So here I'm trying to show you all different types of graph. I'm going to try one more, and then I will do example with the slant asymptote. So this one, vertical asymptote, x cannot be equals to plus minus 2 because that reason, right? Letting denominator equals to 0. Horizontal asymptote, your y will be 0. Why? Because denominator exponent is larger. This is square, this is linear, right? Let's see what kind of symmetry this is. When you replace x by negative x squared minus 4, it gives you negative 4x on the numerator. Denominator, because you're squaring the negative, it will be positive. So isn't that the same as the f of x function given, except you have a negative pulled it out, so it will be negative f of x. This is first time we're seeing it, origin symmetry in this sections, right? But this is how it will look like to find the origin symmetry, right? Origin symmetry. And then let's find x-intercept and y-intercept. So numerator equals to 0 will be x-intercept. the y-intercept is x equals to 0, which is 0, right? And plug in all that information we have. Let's do the asymptote plus 2 minus 2 2 negative 2, and horizontal asymptote is x-axis. The points is 0. X-intercept 0, y-intercept 0. So even though this is horizontal asymptote, because your the intercept becomes 0, it will pass that point. And we wanted to find out what side am I going to graph it, right? So I could have something like this, or I could have something like, no, I cannot have something like this, because that is going to be y-axis symmetry. So it should be something like this, or something like that, right? Or if I have a graph on this area, origin symmetry means I have the graph here, or if I have it here, it should be on the other side, right? So I only need to find where is my points on this and that. It means I will find 1 and 3 maybe by plugging the points. When x is 1, you're going to get 4 times 1 over 1 square minus 4. So that is 4 over negative 3. When x is 3, you get 4, 3 square minus 4, which is 12 over 9 minus 4, 5. So when x is 1, it will be negative. This is negative 1 1/3. This is positive 2 2/5. Somewhere here. 1 2 3. Somewhere over here. No, I need to go up 2, right? So it'll be 2 a little higher. Now I can tell my graph should look like this, and origin symmetry, so it should be on this region. Here, this is my graph, and the other side should be on the bottom then, because again, origin symmetry. So that's how you're going to find the graph for your example 5. Let's look at how to graph with the vertical asymptote. How do I know I'm going to have vertical asymptote? Not the vertical, but slant asymptote. Because this 2 degree is just 1 degree different, and numerator is bigger. Same thing, 1 degree different, numerator is bigger. So it means you're not going to have horizontal asymptote, but you're going to have slant asymptote. So we have 2 examples to go over that. Again, start by vertical asymptote. X cannot be equals to 3. And no horizontal asymptote, because I already mentioned 1 degree higher on the numerator, right? And we have a slant asymptote, and the way that you're going to find the slant asymptote is dividing those 2 functions to get linear. And that gives you 2x times x plus 3 is 2x squared plus 6x. When you subtract, sign change. So you get positive 3x, bring down the next, will be plus 4. X to become 3x, you're going to multiply by 3. 3 times x plus 3 is 3x plus 9. Again, you subtract, sign change. So it will be no more, and it will be negative 5. So this is going to be your slant asymptote. So you have vertical asymptote and slant asymptote. Everything else is same. So when you replace x with negative x, we'll find your symmetry, right? I already know this is not going to be any symmetry because only one half squared. This one is keeping negative. In the same term, one is keeping and one is not keeping. Negative is not going to get back to where we started or negative of that functions. Then we will get something like this, right? One is positive, one is negative. Different sign everywhere. So this is not going to be f of x, not going to be negative f of x, means no symmetry. X-intercept, letting numerator equals to 0. So when you factor, you get x plus 4, 2x plus 1. So x cannot be equals to negative 4 or negative 1/2. Y-intercept letting x equals to 0. That's square plus 9, 0 plus 4, all over 0 plus 3. You will get 4 over 3. And that's y-intercept. Oh, that's not equal. That's going to be x equals 2 because it's intercept, right? And when you graph all that information, you need to mark vertical asymptotes. Let me see, that's negative 3, right? Make sure that's negative 3. So then 1, 2, 3. And then slant asymptote is 2x plus 3. So y-intercept will be 3. 1, 2, 3. Slope is 2. Slope is 2 over 1 means go up 2, move right 1. Draw the linear that passing those 2 points. That will be slant asymptote, vertical asymptotes. Mark all those points that we have, negative 4, and what else we have? 1/2, negative 1/2. Y-intercept 1, 1/3. So it looked like in this area, this large area, you're going to have graph look like this, going toward slant asymptote but never touch, right? And then this is another area you're going to have, not here, not here, right? So only 2 area. That's going to be look like that. So the more information you find, last points that you need to plug in. I'm going to try one more example. So let's just differentiate. F of x equals to x squared plus 1 over x minus 1. So let's do vertical asymptote. X cannot be equals to 1. There will be no horizontal asymptote. And because the exponent is 1 degree different, you're going to have a slant asymptote. order to find slant asymptote, this time I'm going to divide but using the synthetic divisions. So synthetic division, you just use the number. So from x squared, 1x, you have no, right? Constant will be 1, dividing this with x minus 1, which is going to be positive 1. Bring down 1, multiply 1 times 1 will be 1. Add those two numbers will be 1. 1 times 1 is going to be 1. Add those two will be 2. So this one, your equation will be x plus 1 with remainder of 2. So your slant asymptote is going to be x plus 1. So that's something you cannot have. Let's see what types of symmetry this is this time by replacing x with negative x. So then you get negative x squared plus 1, negative x minus 1. You get x squared plus 1 over negative x plus 1. So when you factor negative out, you have x plus 1. Which is not going to be same as f of x or negative f of x. Right, so this is going to be no symmetry. No symmetry means we're going to plug in more points to find both sides of the graph, right? Let's see what else information we have. We're going to find intercept now, right? So you're going to find X-intercept by letting y equals to 0. That means you're going to let numerator equals to 0. So x squared will be equals to negative 1, where x should be plus minus square root of negative 1. That's imaginary value, right? Plus minus I. So you could say there will be no x-intercept. It means your graph should not be touching your x-axis, right? That's good information. And then let's see, y-intercept. Letting y equals to 0, x equals to 0, so it'll be x squared plus 1 over x minus 1 will give you 1 over negative 1, which will be negative 1. So that's going to be your y-intercept. Y-intercept, no symmetry, no x-intercept, slant, and vertical. So let's see if we can apply all that information. You have graph with asymptote. Vertical asymptote x cannot be equals to 1. That's going to be 1. And then your slant asymptote will be x. So that's x cannot be equals to 1. Slant asymptote x plus 1 line, right? So y-intercept is 1. Your slope here, having 1 in front of x, will be 1 over 1 will be your slope, right? So from the y-intercept, you go up 1, move right 1. So it will be that point right there. So draw the line that is passing that 2 points will be your slant asymptote. Right? So you have a slant asymptote. Now let's see, what was your y-intercept and x-intercept? There's no x-intercept. Y-intercept was negative 1. So you will pass that point, not touching x-axis. So smooth curved line passing that in this area, right? This area without touching x-axis should be something going down, right? So your graph should be something like this. So since you found the graph from the vertical asymptotes on the left side, you need to find the one on the right side. Maybe you can plug in 2, right? so that you will know it's going to be on this area or that area. But I kind of already know that it's going to be this area. Why? Because it's a no x-intercept. It means that if I have a graph here, somehow it had to pass x-axis, right? So it not make sense when there is no x-intercept. So having no x-intercept without any points, you kind of know it will be right here, right? But still, you wanted to find one point, so you will know where to start it. So when we plug in x for 2, right? It will be 2 squared plus 1 over 2 minus 1. So it will be 5 over 1, which is 5. So when x is 2, y should be 5. This is 2, 3, 4, 5. So that will be the point. So draw the smooth curved line passing that point and going toward the asymptotes but never touch, right? Something like that. And that's how you're going to graph when you have a slant asymptote. I hope this is enough example for you to review it before you do your own homework. But if it's not, let me know.